water contains many dissolved impurities. Few among them are sulphate and fluoride. Keeping aside sulphate, fluoride causes many health hazards. One of the health hazards caused by fluoride is dentofluorosis. So how to determine the presence of fluoride or sulphate in the water? So let us see determination of fluoride or sulphate in the water sample. So starting with sulphate. Sulphate can be determined by gravimetric method. So we have different methods: volumetric method, that is classical method; gravimetric method, that is a classical method; colorimetric method, that is also a classical method; and spectroscopic method. So today sulphate we are going to determine by gravimetric method. So the basic principle used in determination of sulphate is the water sample in which sulphate has to be determined is treated with barium chloride in acidic conditions. So in acidic conditions, sulphate present in the water will get precipitated as barium sulphate. So by knowing the amount of barium sulphate precipitated, we can estimate how much amount of sulphate is present in the given water sample as follows. The procedure: we are going to take 200 ml of water in a beaker on which sulphate ion to be determined. So we are going to add 5% barium chloride solution drop wise and 1 drop of concentrated solution, HCl solution, so in order to make the water sample acidic. So as soon as we add barium chloride and HCl, so the sulphate present in the water get precipitated as barium sulphate. Thus precipitated barium sulphate will be filtered out. The filtrate is kept aside. The precipitate is dried, is kept in the oven. It is dried and it is weighed. So the precipitate is ignited in the crucible. The crucible is cooled to room temperature and the weight of barium sulphate is measured. From this determined. And let us consider, name it as W1. So barium sulphate or sulphate present in the given water sample is determined by following calculation. 233.4 grams of barium sulphate contains 96.06 grams of sulphate. Whereas 233.4, it is nothing but molecular weight of barium sulphate, whereas 96.06 is molecular weight of sulphate. Whereas W gram of barium sulphate contains 96.06 into W divided by 233.4 grams. Therefore, 1000 ml of water sample contains cross multiply, that is 96.06 into W into 1000 divided by 233.4 into 200 grams. So that gives how much amount of sulphate is present in the given sample. That mainly forms, that is sulphate, depends upon the amount of barium sulphate found. So suppose to completely dry, it should not contain any of the water content. So once the barium sulphate is formed, the precipitate should be completely dried, keeping in the crucible. So it's only completely dried, the water content should be removed when you dry. So as accurately you dry, as accurate W value, accurate results can be obtained by the gravimetric method too. Let us see how fluoride is determined. So fluoride is determined by using SPADNS reagent by colorimetric method. So the main principle used here is, under acidic conditions, fluoride reacts with Zirconium SPADNS reagent solution, and Color of Spadans reagent will be bleached. The color changes with increase in the concentration of fluoride ions. So as the concentration of the fluoride ion increases, the Spadans reagent, intensity of the color bleached in the Spadans reagent also will increase. They are directly proportional to each other. The intensity of the color bleached will be will be measured using colorimetry. The absorbance will be measured. So let us see how to carry out this experiment. So 5 different 25 ml volumetric flasks will be taken. To each of it will be named as 2, 4, 6, 8 and test solution. 2, 4, 6, 8 and test solution. To accept the test solution for the flask name, for the volumetric flasks name 2, 4, 6 and 10, we are going to add sodium fluoride solution and 10 ml of, for 2 ml volumetric flask name 2, we are going to add 2 ml of sodium fluoride. For volumetric flask name, we are going to add, name 4, we are going to add 4 ml of sodium fluoride. Name 6, we are going to add 6 ml of sodium fluoride. 8, we are going to add 8 ml of sodium fluoride solution. And for test solution, unknown solution, let us sample of water is filled in that. So for each everything from 2 to test solution, we are going to add 10 ml of Zirconium SPADNS reagent. So thus we are going to remaining volumetric flask, we are going 25 ml of volumetric flask, we are going to fill it by water sample, by adding distilled water. So all the given fluoride, so we are going to dilute it up to the mark using water. So now we are going to measure the absorbance of these samples at 570 nanometer. So we are going to take 2 ml. First we are going to take a blank solution, so which does not contain any sample, contains only water and zirconium. We are going to keep that. Okay, we are going to set 570 in the colorimeter and set the absorbance as 0. That is, blank value will be 0. Next, take volumetric flask 2, take the solution, check the absorbance. Again, take volumetric flask 4, check the absorbance. Take 6, check the absorbance. Check 8, check the absorbance. Then take the volumetric flask named as test solution and check the absorbance. So as we have seen, from 2 to 8, the volume of sodium fluoride is increasing. As the volume of sodium fluoride is increasing, the intensity of the color bleached also will increase. So therefore, it is directly proportional. So absorbance also will change accordingly. So volume, again, test solution absorbance also will be measured. So we are going to draw a curve, we are going to plot a graph, absorbance versus volume of sodium fluoride, and we are going to determine the calibration curve. So volume of fluoride in water and absorbance will be drawn. From that we are going to determine the amount of or volume of sodium fluoride present in the test solution. So the calibration curve is as follows, that is absorbance versus volume of sodium fluoride. So the curve, the calibration curve should pass to the origin. Why should it pass to the origin? Unlike other experiments, it should pass the origin because for blank solution, absorbance is 0. For 2 ml it might be different, for 4 ml it might be different, for 6 ml it might be different, 8 ml is different. For here, for 0, it is 0. We are setting it as 0. Right. Therefore, in any calorimetric estimations, for blank, for any calorimetric estimation, the calibration curve should pass through 0. So we get a calibration curve. We are going to check the absorbance on the y-axis for test solution. We get some value there. We are going to extrapolate it until it touches the curve. Once it touches the curve, from there we are going to draw a perpendicular to x-axis. So we are going to take the absorbance of the test solution on the y-axis and draw a parallel line to x-axis until it touches the calibration curve. Once it touches the calibration curve, we are going to drop a perpendicular to x-axis. So whatever value you get there, that is the unknown volume of the fluoride present in the test solution. So this is how fluoride concentration is determined using colorimetric method. So now, by development of ion selective electrodes, so this is the classical method. But now, by development of the ion selective electrodes, as soon as we dip the pen like this electrode in a water sample, immediately it gives the concentration of fluoride, it gives concentration of calcium, it gives concentration of magnesium. This is the major contribution of invention of ion selective electrodes. This is the classical method, but recently we have a separate electrode for fluoride. So this used to take many days to determine the, once you send the water sample to the center, testing center, they give you the date, then they give you the report. But now immediately you can know how much water, how much fluoride is present in your bore water or well water, whether it is potable or not. Depending upon that, the fluoridated water, we can check, we can decide whether the water is used for drinking or not. Thank you.